Alright, now we're doing lesson 5.3, and this is actually a 2-day lesson, so there's going to be a lot of notes. But we have a lot of new terminology and diagrams to draw, so this would be one of those lessons that if you are watching videos, it might be helpful to catch up on the notes, or it might be easier to watch for a while and then do the notes. But you're going to hear me say, like, this is the only thing we're going to do with this, so make sure you're paying very close attention to what we're going over. The next one is we're using perpendicular bisectors and angle bisectors. We're going to get 2 new definitions today on things that are going to be helpful in the future and in terminology and geometry. And so no, this is just one of those loaded lessons. So here's a few things we need to understand. The first thing we need to remember is that we have 3 sides of a triangle. Now everyone's like, Mrs. Gregerson, that's not earth-shattering news. But if we have 3 sides of a triangle, we have 3 different line segments. We also have 3 different angles. So today, we're going to work with perpendicular bisectors again. Now remember, a perpendicular bisector goes through the midpoint and forms a right angle. Now notice how I drew this. This is the helpful hint thing you need to remember. When I draw it, I actually ignore the fact that there's a triangle there. I just draw the perpendicular bisector for that segment. I ignore the rest of the triangle. And when you do that, you don't automatically assume that it's going through this vertex of the angle opposite it. It helps you draw it more accurately. Now, we have some new terminology too. When you have 3 lines intersecting all in the same place, those lines are called or said to be concurrent. Now remember, con means with. So they're all current with each other. They all share one point. So those are going to be concurrent. Now, where they meet is called the point of concurrency. So today, our whole lesson is about how we form points of concurrency. Now, when we do constructions, which are down below, you're going to see how we form the point of concurrency. Now when you do that, and I do it with the perpendicular bisectors, when I have 3 perpendicular bisectors, okay, they will have a point of concurrency. Now let me show you down below what I'm talking about. And then we'll come back up. When you have a triangle, and I'm drawing the perpendicular bisector, I go to the midpoint, and now understand I'm freehanding this, so this is not going to be perfect. You go to the midpoint, you draw your segment, so you have your right angle being formed, and you know those 2 are the same. Now I keep moving the triangle around, and I find the midpoint, and I'm going to draw my right angle going in. Those 2 are the same. I'm going to do the same thing here. I get my midpoint. And the reason why I can do this at all accurately is just because I've drawn these so many times before. But notice they all intersected in one spot. Now I'm going to do that for the other triangles down below, but here that point of concurrency is called the circumcenter of the triangle. So here's my new term, circumcenter. A circumcenter is where the perpendicular bisectors intersect, okay? Now, let's do that for an obtuse triangle, and let's do it for a right triangle. Now, if I do it for the obtuse triangle, again, I'm going to move this triangle, this piece of paper around. I'm going to go to my midpoint, so I know those are the same, and I'm going to extend it, making sure I make my right angle. I'm going to do the same thing on this side. I'm going to make sure it's parallel to my body, otherwise it doesn't work as well. Here's my midpoint. I know those are the same. I'm going to draw it so I have a right angle. This part is probably the hardest thing for people to do, drawing the right angle. And then I'm going to go to the far side, and I'm going to go through to the midpoint. The midpoint's about right here. And I'm going to draw this side. Notice they still intersect. That's your circumcenter, okay? So when you do that, notice with the obtuse triangle, it's going to be on the outside. When it was an acute triangle and all the angles are acute, the circumcenter is on the inside. But what about a right triangle? And this is the one you really want to know. This is the only really type of circumcenter we're going to work with. So on that, I'm going to do the perpendicular bisector again. Okay, I'm going to do it on this side. And if I do the perpendicular bisector on the hypotenuse, look where it hit already. Smack dab in the middle. If you're not sure, go ahead and get out a ruler if you'd want. But I think this shows pretty quickly where it is. The circumcenter here is on the circle. This is the only type of circumcenter we're going to use. Did everyone hear me on that? That's the only one we're going to use. So here's the circumcenter. There's the circumcenter. I'm just going to go CIR for the moment. And here is our circumcenter. All of those are being formed. Now, they all are concurrent. They all intersect right there. So what's going to be my rule here? Well, when I have the circumcenter of a triangle, we know that it is equidistant from the vertices of the triangle, which means these, I'm going to use, I'm going to use an X here to just grab that. That these three segments right here are the ones that are going to be the same, and that P, let's go like this. Point P is the circumcenter. Hopefully that will help us a little bit. And let me show you some examples of what we're going to do. We'll do that on the next side.